Vehicles traveling the nation's highways sometimes weigh in excess of 40 tons. In order for these large vehicles to stop safely, it is imperative that their brakes work properly. The most common brake system in use on heavy motor vehicles today is the air brake system. In this videotape, we will examine the principal components in a typical S-Cam air brake system. We will begin at the wheel and work our way back through the entire system. What exactly happens at the wheel the instant a driver applies the brake? In order to answer this question, let's remove the wheels on this dual assembly for a closer look. This can be accomplished by removing the outer wheel nuts, the inner wheel studs, and some retaining bolts which secure the brake drum. The component now being removed is the brake drum. It is made of cast iron and is fastened to the wheel hub. The inside surface of the drum should be smooth and not rusted, cracked, out of round, or contaminated. With the brake drum removed, we can see more clearly what happens when the brake is applied. We are now looking at the brake linings, which are forced to move or pivot upon brake application. To see exactly what the brake linings move against, let's put the brake drum back into position. As the brake is again applied, watch the brake linings move and contact the drum. Now, with the wheels back into position, watch the wheels stop as the linings are forced out against the drum. Adequate friction at the drum will in turn stop the wheels and the vehicle. Brake linings should not be excessively thin, cracked, or contaminated with grease or oil. Let's go back and examine each brake component in more detail. The brake lining is connected to a metal surface called a shoe. The lining and shoe are usually fastened together by rivets. There are 2 brake shoes at each drum. The brake shoes and linings are held in place by the spider casting, called the spider for short. The spider is mounted to each end of the axle housing. This casting should not be loose or cracked. The spider holds one end of the brake shoes with anchor pins. When brakes are applied, the brake shoes pivot on the anchor pins. Anchor pins may sometimes rust, thus freezing the brake shoes in either the applied or released position. When the brakes are released, return springs pull the brake shoes and linings back away from the brake drum and hold them stationary until the brakes are once again applied. These springs are highly stressed and may fail due to corrosion. The next 2 brake components we will discuss are the cam rollers, located at one end of the brake shoes, and the S-cam shaft. Watch these components as the brakes are applied and then released. When the brake pedal is depressed, the camshaft rotates. As the shaft rotates, the cam rollers ride the S-shaped cam to its high point. This action spreads the brake shoes, which in turn forces the linings to contact the brake drum, bringing the wheel to a stop. Friction between the brake linings and the brake drum produce heat. The brake drum absorbs this heat, then dissipates it into the atmosphere. Brake drums may sometimes become distorted or severely cracked. They can also become contaminated with oil or grease. These situations could result in partial or complete brake failure. What causes the camshaft to rotate? In order to answer this question, we focus our attention on the brake chamber, push rod, and slack adjuster. When the brakes are applied, air in the brake chamber forces the push rod out against the slack adjuster, which in turn causes the camshaft to rotate. Now let's take a closer look at these individual components. Brake chambers are mounted near each wheel and are used to convert the energy of compressed air into the mechanical energy required for braking. Let's examine the inside of a clamp-type spring brake chamber. The brake chamber is divided into two parts: the service chamber side and the spring brake side. The service side of the chamber provides braking for normal driving needs, such as slowing down or stopping. The spring brake side of the chamber is used for parking and emergency braking. Primary components in the service brake side of the chamber include a rubber diaphragm, return spring, push rod, and plate. When the driver applies the service brakes, compressed air is forced into the service brake side of the chamber, moving the diaphragm and in turn the push rod. The spring brake side of the chamber includes a second diaphragm and a powerful spring that are used for parking and emergency braking. Air pressure in the spring brake side keeps the large spring compressed, holding it ready for parking or emergency braking. When the driver wishes to apply the parking brake, a dash-mounted valve is used to exhaust air from the spring brake side of the chamber. Notice the pressure gauge needle on the right as air pressure falls in the spring brake side of the chamber. This causes the large spring to expand, forcing the push rod out of the chamber and thus applying the brakes. If for any reason the air supply should fall to a dangerous level and the air pressure is no longer capable of compressing the spring, the large spring will automatically expand and apply the emergency brakes. Brake chambers should be free of leaks, bent push rods, loose mountings, missing air fittings, and chafed hoses. No matter what type of braking is needed, the brake chamber always begins the braking process by forcing the push rod out against the slack adjuster. The push rod is the link between the brake chamber and the slack adjuster. The push rod is connected to the slack adjuster by a yoke and clevis pin. Without this connection, the brakes would not function at that wheel. Slack adjusters take linear motion from the push rod and change it into rotary motion at the camshaft. The slack adjuster, essentially a lever, also substantially increases the amount of force it transfers from the push rod to the camshaft. The camshaft has grooves that allow it to fit into the slack adjuster. Slack adjusters are equipped with an adjusting mechanism to compensate for brake lining wear. This device is important because as brake lining wear progresses, the push rod must travel further to apply the brakes. Some slack adjusters perform this adjustment automatically. To check for proper adjustment, push rod travel is measured. Brake chamber size and type must also be verified in order to check for allowable push rod travel. With a properly adjusted brake, a slack adjuster and push rod should form about a 90-degree angle with the brakes fully applied. Let's take some time to review all we've covered so far. When the brakes are applied for service braking, air enters the brake chamber, diaphragm moves the push rod forward, slack adjuster rotates the camshaft, S-cam rides the cam rollers, rollers force the shoes to spread, linings contact the brake drum, and finally the wheel stops. Thus far, we have examined each brake component starting at the wheel and moving back to the brake chamber. Next, we will examine the principal components which compress, clean, monitor, store, and direct air to the brake chambers. Let's begin by learning about the air compressor. The air compressor is an engine-driven mechanical pump which is the energy source for any air brake system. The compressor's output is controlled by the governor. When air pressure drops below a certain point, the governor activates the compressor. When air pressure returns to normal operating levels, the governor deactivates the compressor. From the compressor, air is directed to the air dryer, where it is cooled, filtered, and dried. The air dryer removes contaminants and moisture from the system. From the air dryer, compressed air is routed to the tractor's reservoir tanks, where air is stored until it is needed to apply the brakes. Usually, there are 3 reservoirs located on the tractor and 2 on the trailer. Air is routed to the various brake components through hoses and tubing designed to resist corrosion and high pressure. A series of valves throughout the system direct, signal, and relay air, as well as control pressure to the brake components. Hose couplers, or glad hands, quickly connect air hoses from the tractor to the semi-trailer. Once these connections are made, compressed air will be routed to the trailer's reservoirs. Compressed air is routed through this complex system of reservoirs, air lines, and valves in such a way to ensure that the tractor would still be able to stop, even if part of the air system were to fail because of trailer separation or severe airline or reservoir leaks. Let's now move inside the tractor cab and examine the controls related to the brake system. Gauges mounted on the dash allow the driver to monitor air pressure in the reservoirs. If reservoir pressure should drop to a dangerous level, a visible warning device alerts the driver. This is called the low air pressure warning device. For normal stopping, the driver applies the service brake by depressing the brake pedal, sometimes called the treadle valve. When this pedal is depressed, brakes at each wheel are applied. If the driver desires to apply only the trailer brakes, a hand valve mounted on the steering column or the dash is used. Parking and emergency brakes are controlled by other push-pull valves located on the dash. To apply the parking brake on both tractor and trailer, the yellow valve is pulled out. The red valve controls the spring brakes on the trailer only. If air pressure is ever unexpectedly lost, the emergency brakes on the trailer would automatically be applied by the spring portion of the brake chamber, and the red valve would pop out. Let's briefly review the components involved in the routing of compressed air to the brake chambers. A compressor supplies pressurized air for the braking system. The governor regulates the compressor's output. An air dryer cools, filters, and dries the air from the compressor. Reservoirs on the tractor and trailer store the compressed air from the compressor until needed to apply the brakes. A series of valves throughout the system monitor, signal, relay, and direct air to brake components. Hoses and tubing move air through the system to the brake chambers. Hose couplers, or glad hands, quickly connect air supply from tractor to trailer. A foot pedal applies service brakes at each wheel. The hand valve applies trailer brakes only. Dash control valves regulate spring brakes for parking and emergency braking. Air enters brake chamber. Studies have shown that brake failure is a leading cause of commercial vehicle accidents. It is imperative that such critical items as brakes be inspected properly and that the inspector have a good working knowledge of component function. Proper inspection of an S-Cam air brake system may prevent a serious accident and make our streets and highways a safer place to travel.